So in this question, you are asked, why is carbon-14 useful in finding the age of objects? So the reason why it's useful is because it undergoes beta decay in a very predictable way, and it has a half-life of 5,730 years. So if you remember, so if we take, so this is carbon-14. Okay, so it breaks down into nitrogen, and it also gives up this high energy electron, which is what beta radiation is. And this is -1 plus a lot of energy. So what's essentially happening here is you have, so carbon-14, so it contains 6 protons and 8 neutrons. And what happens is that one of those neutrons actually changes into a proton. And as a result of that, you can see here that the atomic number, which represents the number of protons contained in the atom, it increases to 7. The mass stays the same because the mass of a proton and the mass of a neutron are the same. So all that happens is you get a neutron, it changes into a proton, and as a result it increases the atomic number by 1. So therefore carbon decays into nitrogen. Mass stays the same. Now that excess energy that from that change from the neutron into the neutron into the proton, it's emitted in the form of a high energy electron, and there's energy given off that as well. And this is what's known as beta decay. And it takes, so if you have, for example, if you have 10 carbon-14 atoms, after 5,730 years, you're going to have 5 carbon-14 atoms, because half of the carbon atoms that you started off with will have gone through this process of beta decay, and they'll have changed into nitrogen atoms. So that's why carbon-14 is useful in finding the age of objects. And also as well, a lot of the objects that you're dating will contain carbon in them. So anything that contains carbon, so for example the bones of animals, paper for example is made from trees, and trees absorb this carbon-14 from the air. Okay, so that's that one.